Oliver and Enrico. They are the engineering manager and senior software engineer from SUSE. So they will be talking about a prescriptive approach to application development with Epinio. Thanks, Oliver and Enrico.
Thank you very much for giving us this opportunity to talk here at the Hong Kong API Days. As today we would like to come back around our key thoughts from our own SUSECon 2023 about API developer experience.
A prescriptive approach to application with Epinio. Hi, from Belgium. My name is Olivier. I'm an engineering engineer from SUSE, working on various application deployment solutions. The first one is Fleet or GitOps approach for Rancher. Kubernetes, with a security policy engine. And finally, Epinio, which is the thing we're going to talk today.
Hi everyone, my name is Enrico and I'm from Italy. I'm a senior software engineer at SUSE, working on the Epinio project.
So after this quick personal introduction, let us jump in our topic. As we like to say at SUSE, our goal is to give you the freedom to innovate everywhere, and that's exactly what we're going to talk about. So our teams are working very hard on many different topics, and the one that I want to talk today is what does it take to go from code to real as easily as possible. And by code, I mean that awesome application that your team is working on, no matter the programming language. And by URL, I mean that endpoint that your users uses to visit your awesome application. Many of us deploy countless applications to production, so we learn there are common deployment patterns, and we want to empower developers to let them deploy application in the most efficient way. And the project we're going to talk today is one of them. So let me introduce Epinio. Epinio is an application development engine leveraging Kubernetes and what we believe to be the missing components between developers and operation, or platforms engineers, as we like to say nowadays. So let's step back a bit. When it comes to developers, we made three assumptions. The first one, developers want something easy to learn and to debug. Second, developers are already busy enough on development side that they don't want to learn new tool. And third, developers are looking for a self-service provisioning tool. And so basically that whole idea of asking compute resources via ticketing system is just a thing of the past. That should be quick nowadays. On the other side, operation people are looking for stability and predictability. So from an operational perspective, the final goal remains the same than for developers, which is delivering value to customers. But the way to get there implies a different mindset. From a SUSE lifespan, the way of managing infrastructure evolved a lot over the past 3 decades. So we went from deploying Linux operating system 30 years ago on hardware that probably needed to be requested via a ticketing system back then, which would take a few months, to a world where everything can be seen as an API to provision and configure our infrastructure. This API world allows us a new level of automation, and one of the projects leverage this API, which is the Kubernetes project, and it provides us so many infrastructure abstraction. So the question is, do you need to deploy a high availability load balancer? Well, it's probably an ingress you're looking for. No matter the cloud provider, do you need to provision storage? Well, you can probably look at persistent volume, for example, using the Longhorn storage or any other storage provider. Or are you looking to enforce signed containers in your infrastructure? Well, a security policy engine like Kubernetes is definitely the thing you want to use. And due to all those standard APIs provided by the Kubernetes project, that project became de facto the standard way of managing infrastructure. So the idea that developers should be able to deploy to production just by interacting with a service is not something new, right? According to Wikipedia, Zimkey, which appeared back in 2006, seems to be the first PaaS, where PaaS stands for Platform as a Service. And even though the concept of a PaaS has been around for a while, we still see high demand from our customers for being able to quickly deploy services to production. And we learned over the past years that traditional PaaS are not flexible enough. While it can work great for some organizations, many of our customers have specific needs when it comes to cloud providers, data retention, hardware. And at Suze, we felt like our goal went from to give you the freedom to innovate everywhere to give you the freedom to innovate everywhere by doing what we tell you to do. And it didn't sound right to us. So traditional PaaS are, I would say, very opinionated. And that feeling resonates very well with a tweet from Kelsey Hightower back in 2017, where he said, I'm convinced the majority of people managing infrastructure just want a PaaS. The only requirement is that it has to be built by them. And from the learning, it's probably the most important one. We want to build a new flexible, opinionated platform. So, welcome IDP. This brings us to that new shiny marketing word, IDP, which stands for Individual Platform Developer. And to be honest, I'm not really into new fancy marketing stamp, but we need to learn from the past. That self-service platform should be opinionated enough to enforce good practices, while being flexible enough to adapt to as much business constraints as possible. And the great thing is, since 2006, when Zimkey was first introduced, our ecosystem evolved so much that we now have a lot more opportunities when it comes to automation. Which brings us to Epinio.
So thank you, Oliver, for the introduction. So let's talk a bit now about Epinio. So Epinio is a really flexible solution to build your own platform as a service on Kubernetes. And it comes with batteries included. By saying that, I mean that it's shipped along with everything it needs by default. You can install it with an help chart, and it will internally install some of its dependencies. For example, it will use MinIO as an S3 compatible storage and an internal Docker registry where to upload the built images. But if you want to use something else, you're good to go. If you want to try the S3 gateway, it's an available opt-in. Or if you want to use an external S3, for example, on AWS, you just need to provide the needed configuration. Also, regarding AWS, we support AIM authentication. So you can just set up a service account with the right policy in order to authenticate without worrying about providing any further credential. And in the same fashion, you can use your own registry. So you will have full control on where to upload your images. You can obviously use any Docker compatible registry, such as ECR or Artifactory. In Epinio, we believe in standards, so we are not using custom or fancy approaches to deploy applications, but we are using Helm. So Helm is a graduated CNCF project, and it's one of the most used and well-known package managers for Kubernetes applications. And it lets you define even the most complex architecture in a flexible way with the standard YAML templates. And we have packaged a standard app chart in Epinio to deploy applications. It will create everything your application needs to run into your cluster in a minimal but resilient way. So it will create a deployment to scale your pods and an ingress and a service that will be used to reach your application from the outside. Still, if it doesn't fit your needs, you can build your own chart and use it, leveraging values to customize your deployments. And with the same idea, we built our service catalog. So an application usually needs a database or some external service to work properly. And your developers are maybe using Node.js with MongoDB, Redis for caching some data, or standard SQL databases such as Postgres or MySQL. And you would like to provide these services to your developers with a self-provisioning approach without opening tickets or handling these requests manually. And cluster administrators are usually working on more complex things, and They don't want to spend too much time provisioning a new database for a new application and stuff like that. So with the service catalog that still uses Helm under the hood, the operators can define the services ahead and let the developers provision them by themselves. Also, having a flexible authentication system was another goal that we achieved with Epinio. We started with a simple basic authentication approach using Kubernetes secrets, and we expanded it with DEX. And DEX is another CNCF project, and it's an OpenID connect provider. So you can configure DEX to use any of its supported connectors to log in with your favorite single sign-on platform. For example, you can use it with AWS and SAML, Google accounts, GitHub, LDAP, and many more. Epinio has also a simple authorization system with two roles. An Epinio user can be a regular user or an administrator. When logged in as an admin, you will be able to perform any operation, while a regular user will be restricted to its namespaces. So it won't be able to manage or even see applications running on other namespaces that were maybe created by other users and teams. This gives Epinio a light multi-tenancy capability that isolates departments, providing them safer environments. I would like to say that if you're using the single sign-on option to log in, you can use groups to map users to different roles. So the 12-factor app is a methodology for building distributed applications that run in the cloud and are delivered as a service. These best practices are designed to enable applications to be built with portability and resilience when deployed to the web. I'm not going to cover these 12 factors, but they are important concepts that you should be aware of while building cloud-native applications. For example, the importance of having a single code base tracked in a vision control system, or storing the configuration in the environment, and running stateless processes to its horizontal scalability. Regarding the build process, I would like to say that we use one more CNCF project that are cloud-native build packs, and they provide a modular way to go from source code to container images. They will auto-detect the programming language, perform the build, package, and push the image to the registry. So after the building phase, Epinio will take care of the deployment using the specified app chart. And like that, we have seen how Epinio is opinionated. So we are doing some assumptions using specific technologies and workflows, but still it's not that opinionated. You can tailor it to fit your needs and requirements. You can have custom application charts for different deployments. You can have your own builders for more complex applications, and you can have different external dependencies. And you can even have a completely custom service catalog. So in the previous slide, I covered the aspects targeting more the operators and the organization, but the end user of Epinio is still the developer. And we already say that you shouldn't worry about knowing Kubernetes, that it's a really challenging infrastructure, or learning a new complex tool. And we provide a cross-platform command line interface that can be used to interact with the Epinio APIs. And we also have a web UI that I will show you later that can be used to deploy and manage your applications with just a few clicks. We have already said that Epinio should ease your deployments, and so we focus on giving the developer a single-step push command. So with just an Epinio push, it's possible to upload, build, and deploy an application. The source code can be uploaded from the local file system, fetched from an external Git provider such as GitHub or GitLab, or if you already have built an image, it can be directly used, skipping all the building process. Also, we already covered the service marketplace feature from the operator perspective. And by default, we provide as an example a set of common services from the Bitnami charts. So we have MySQL and Postgres, Redis, MongoDB, and RabbitMQ. The operators can customize and expand this catalog, preparing custom health charts, and the developers will see all the available services. So with a single command, they will be able to deploy what they need with a self-service approach and bind these services to their application. And we always hope that everything goes right, but the developer will still need some tools to check that its application is running properly or to debug it. So Epinio has a set of commands for this. You can access the application logs and filtering them. And if you need to check the container, you can even open an interactive shell into it. And if needed, you can even open a tunnel to attach a remote debugger for a deeper investigation. But now it's time for a demo. So let me show you how Epinio works. I have K3S cluster running locally, and I have installed the latest Epinio version, that is the 181 at the moment. I'm going to log in with the default admin user, and I will be redirecting to the first page, that is a dashboard that will show you all the application and services and namespaces that are in your Epinio cluster. So let's try to deploy an application. Here you can see that you can load the source code from your local file system and archive on a folder. You can use an existing container imager, or you can fetch it from a Git provider. Let's try with GitHub. I'm going to use our Epinio organization that contains several examples. So let me just use the Java one. I'm going to select the main branch, and I'm going to select the commit that I want to use to deploy. Here from the advanced setting, you can choose, for example, your own custom builders or custom application chart. Let's just click next. I will prompt to fill the name. Let's just put sample Java. I can choose the number of instances that I want, any custom routes or any variables that are coming from the application chart. Let's just leave the default and click next. Here we can bound any existing configuration or services. I have none, so just go on create. And this is going to be the final step. So Epinio has created the application. It's going to fetch the source code from GitHub, and the build packs are now starting the build. On the bottom, there is this shell that is showing me all the building phase with all the logs coming from the build packs. And in just a matter of few minutes, it will complete the build, package the images, push into the containers, into the registry, and then Epinio will take care of the deployments. So let me show you this example Java application that is here while it's building. And it's just a simple hello world example coming from the Spring Boot starting a quick start page. So it's just an hello world. And it's now complete. So as you can see, it was detected as a Java application, and it's finalizing the build. Meanwhile, let me just going through the dashboard, so I will show you the other pages. So here on the left, we have the services catalog, where you can see all the available services, and you can, for example, provision any of them in just a matter of few clicks. Let's see how the build is doing. So it seems that it's done. As you can see, the build packs have prepared the images, and now it's going to push them into the registry. It's already deploying the application. So here we are. So as you can see, in just a matter of few minutes, we have our application up and running, and these are the logs coming from the application. We can close these logs from here. We don't need them, and just click on done, and we will be redirecting to the application's details. So from here, we can click on the URL when we can reach our application. And from here, you will have some details about it. You can scale it, and on the top right, you will have everything you need to perform some kind of investigation. For example, we can check the logs, filtering them if you want to find something interesting. And with the app shell, we'll open a shell a terminal into your container, and we can do everything we want. You can still build the application, restart the images, also exporting the application if you want to import in a cluster, and everything you need to do. And here you can see some details about it. So for example, the number of instances that are running, the bound services and configuration, and that's it. So that was just a quick demo to show you how easy and quick is to deploy an application from starting just from the source code and having the final URL ready for your users.
Thanks, Enrico, for this demo. Maybe something that I want to highlight before we conclude this presentation is we saw we have two customers or users, Epinio users, those who prefer to remain in the UI, and so they can also leverage Rancher UI. So if they have like a lot of information provided by Rancher, and at the same time, some people prefer to just do everything from the console. And so we also provide a small CLI, and you can do pretty much everything we saw here just by using the CLI. Just to conclude this presentation. So if you're not a developer, neither a Kubernetes administrator, and yet you are listening this presentation, I'd love to know more about you and see how we can help you. And in any case, do not hesitate to try Epinio. It's a great project.
And this concludes our presentation for this Hong Kong API Days. Feel free to reach out if you have any questions.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.